Alright, so let's do a physics problem. This is a two-dimensional kinematics physics problem. Now the big thing about this I want y'all to know is that the y component and the x component are going to be completely independent of each other. Okay, so when it says how long does a projectile take to hit the ground below, then in essence it'd be the exact same thing as if I had this y component here, threw it straight up and came straight back down. So let's do that first. What I can do, I can completely ignore the x component for part A. Now, it's thrown at an initial v0, alright, at a given theta, which means this y component, since it's opposite my angle, this y component is going to be v0 sine theta. Now, let's also talk about some things. The amount of time it takes to get to the highest point and to come back down to its original point is the exact same amount of time. So what we're going to do is we're going to find out how long does it take to get to its highest point, multiply it by 2, and that's how long it's going to take to go up and then back to level with the cliff. Now look at these three equations right here. These are your three basic one-dimensional kinematics problem, okay? Whenever you're doing 2D, you're going to do your y components individually, x components individually. So these are for constant accelerations in one dimension. So let's go ahead and do the y component for this. Now, I want to find the time it takes to get to its highest point. So I could use either, we'll call this 1, 2, and 3. I can either use equation 1 or 3, because equation 2 doesn't give me time. Now, I want to use equation 3, and here's why. The final velocity at that instantaneous moment, at its highest point, this final velocity will be 0. So our VF is going to be 0. Our initial velocity is going to be v0 sine theta. Our acceleration is going to be our acceleration due to gravity. And since we are pointed up, that's going to be positive, down is going to be negative, this is going to be a negative g. And time is what we are looking for. Okay? So, if I put in this equation, if VF is equal to v0 plus 18, by plugging all these in, I have that 0 is equal to v0 sine theta minus gt, where v0 sine theta and g are all known. To solve for t is going to be v0 sine theta divided by g. And this is how long it takes to get to the highest point. So, to get to the highest point and back, I'm just going to multiply this by 2. So we'll call this T1. T2 is going to be the same thing. And so we'll call big T1. The big T1 is going to be the time it takes to get to its highest point and back to the original spot. We'll call this big T1. This is going to equal 2 times v0 sine theta over g. And now let's find a big T2. Big T2 is going to be the time it takes to get from the top of the cliff down to the bottom. Okay, now what we're going to want to do here is we have a couple of options. And let's talk about our options. I can use this second equation, okay, to find the final velocity. And when I find the final velocity, I can then use this equation to solve for time. So that's option 1. Option 2 is I can use this equation straight up and just do a quadratic. So let me show you both options in order to find T2. So let us find T2, and I'll show you both options, and that way you can choose whichever option you want to do. So let's do option 1. Now what I can do here is, since this is a completely separate system, and whatever I had up top I completely ignore for a sec, I'm going to call down the positive y just for this system. Okay? So using the first equation, so using equation 1, I have y final is equal to y initial plus v naught t plus 1/2 at squared. I'm going to call this my initial y, and this y naught will be 0, and this y final will be h. Okay, so I have yf is equal to h, y naught equal to 0. Now v naught, the exact same, it went to go up at that point, the exact same velocity at this point going up will be the exact same velocity going down. So this v naught is still v naught sine theta, and it's positive because even though it's pointing down, I called this the positive y direction, and then a this time will be a positive g. So by plugging all of that in, what I get is 0 is equal to, h is equal to yf. H is equal to 0 plus v naught sine theta t plus 1/2 gt squared. So let's go ahead and make this a quadratic. I have 1/2 gt squared plus v naught sine theta t minus h equals 0. And now from here you can apply the quadratic formula and solve for t. So that's option 1. Now let's look at option 2. Option 2 says, let's find this final velocity, and it will be the final velocity at this point, and once I have this final velocity, I can plug it into equation 3 and just solve for time. Okay, so let's try that. Vf squared is equal to v naught squared plus 2a delta x. And all delta x is the distance traveled. Okay, so Vf is what we're looking for. V naught is still v sine theta. And then a is still g. I'm keeping the same direction. Positive y is still going down. And delta x is equal to h. So I have that Vf is equal to, it's going to be the square root of v naught squared. So v naught squared sine squared theta plus 2gh is the square root of all of this. Once you find the final velocity, we plug this final velocity into equation 3. And so I'd have that Vf is equal to v naught plus at, where Vf is equal to that Vf. V naught still v naught sine theta, a is still g. And so what I would have is t is equal to Vf minus v naught over a. Where, same mention, v naught still this and a is still g. And this is another way, this would be your, I guess, capital T2. And so to find the total time it takes to get from here, shot up, and to hit the ground on the bottom, it's going to be your T1 plus your T2. However way you want to solve it. So that's going to be part A. So the total time is, so I guess, part A, total time is T1 plus T2. Alright, let's look at part B. Part B says, how far away from the cliff does it travel? This is wonderful, okay? Because now, since it's in the x direction, I'm going to do that completely independent of the y direction, okay? And the x component, this x component is going to be, since it's adjacent to the angle, is v naught cosine theta, okay? And what is distance? The distance traveled is equal to velocity times time. Or what you could have done, you technically could have used this first equation where your initial is 0, acceleration is 0. That's important. Acceleration in the x direction is 0. You are at a constant velocity, which is why I can use that distance is vt. And I'm looking for d is what I'm looking for. And v is going to be v naught cosine theta, because this is in the x direction. And this t is equal to your T1 plus T2 you found earlier in part A. And so D, the distance traveled, how far away, is going to be V naught cosine theta times your